subnetting a little bit. Today we will take a look at the following relating to IPv4 addresses: CIDR notation, the prefix length, subnetted addresses, and private IPv4 addresses. CIDR is classless inter-domain routing. It is not restricted by the rules governing classful addressing schemes. When CIDR notation is used, the address is formally considered classless. It does not adhere to the limitations of traditional Class A, B, or C addresses. It allows for efficient allocation of IPv4 addresses, so it contributed to their preservation. It slowed down their depletion. CIDR notation uses the prefix length to denote the number of network bits in an IPv4 address. It represents the number of bits associated with the network portion. The prefix length is added at the end of the address. It employs a convenient notation to denote the number of network bits. For example, in the address 10.0.0.0/8, the /8 is the prefix length. This indicates there are 8 network bits in the network portion. In 172.18.0.0/16, the /16 is the prefix length. This indicates there are 16 network bits in the network portion. And finally, in 192.168.5.0/24, the /24 is the prefix length. This indicates there are 24 network bits in the network portion. We can use the prefix length to quickly determine if an address has been subnetted. If the prefix length specified in the address equals the native prefix, the address has not been subnetted. Consider the first two Class A addresses. The prefix length used is /8. This equals the native prefix because Class A addresses have 8 network bits. This means these addresses have not been subnetted. Consider the next two Class B addresses. The prefix length used is /16. This equals the native prefix because Class B addresses have 16 network bits. This means these addresses have not been subnetted. Similarly for the last two Class C addresses. The prefix length used is /24. This equals the native prefix because Class C addresses have 24 network bits. So these addresses have not been subnetted either. On the other hand, the addresses shown here have all been subnetted because the prefix length specified, such as /11, /18, and /21, do not match the native prefix. Therefore, all of these addresses have been subnetted. Pay special attention to the address with the /24. Since the first octet is 172, it is natively a Class B address. So its native prefix length is /16. However, since a /24 is being used, it can be concluded that this address has been subnetted. Keep in mind that simply using, for example, a /24 does not change the native class of an address to a Class C. The native class of an address can never be inherently changed. Let us now look at private IPv4 addresses. Private IPv4 addresses are a reserved range of addresses. They are not routable as far as the Internet Service Provider is concerned. If the ISP receives a packet with a private IPv4 address as the destination, it will drop the packet and not forward it. Private IPv4 addresses require Network Address Translation, or NAT, to route private IP addresses on the Internet. NAT is typically performed by a router. NAT translates a private address to a public address. Public IP addresses are routable. Private IP addresses are used for internal network communication. Every organization can use them internally, and there will be no conflict. Shown here are the ranges for the private IPv4 addresses. There is one range for each class. Let's look at how the private IPv4 address ranges are determined based on the prefix length as specified by the standard. Class A is easy because the prefix length sits at an octet boundary. To get the beginning of the range, set all host bits to 0. This gives 10.0.0.0. To get the end of the range, set all host bits to 1. This gives 10.255.255.255. For Class B addresses, since a /12 is specified, this means the first 12 bits are fixed and frozen. They cannot be modified. To get the beginning of the range, leave the first 12 bits intact and set the remaining 20 bits to 0. This gives 172.16.0.0. To get the end of the range, again, leave the first 12 bits intact and set the remaining 20 bits to 1. This gives 172.31.255.255. The Class C private IP address range specifies a /16. This means the first 16 bits cannot be changed. To get the beginning of the range, set the remaining 16 bits to 0. This gives 192.168.0.0. To get the end of the range, set the remaining 16 bits to 1. This gives 192.168.255.255. Recall, to get the total number of networks, use the formula 2 to the n, where n is the number of network bits in the address map. This means that without subnetting, the total number of networks possible in the Class C private IPv4 address space is 2 to the 8th, or 256. Recall the first 16 bits are frozen and can't be modified. The total number of addresses is 2 to the h, where h is the number of host bits in the address map. Since there are 8 host bits, we can have a total of 256 addresses in each network. For usable addresses, recall the formula 2 to the h minus 2. This means there are 254 usable addresses in each network. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.